So, welcome, Dr. Sarsour, Ehab Sarsour from the Kansas City campus. I just have a couple questions for you about your research that you're performing up there. And first of all, if you could start by just giving us kind of a quick elevator pitch of your current research focus.
Okay, so thank you, Dr. Kramer, for hosting me for this little interview. So my research focuses on the stromal aging, specifically human fibroblast aging, and how that the basic processes of aging affect the disease microenvironment. So that's the focus where we showed that during aging, these fibroblasts go through some kind of metabolic shift where they are more dependent on lipid lipolysis and signaling, and that creates some kind of pro-inflammatory conditions in these cells that can affect many disease systems, including cancer, neurodegenerative disease. Also, it can affect wound healing and can explain many of those age-associated clinical conditions that arise due to the aging process and the virility and fragility of cells as they age. And I'm concentrating on fibroblasts because fibroblasts actually are basically a building blocks for most of the tissues in the body. They remodel the tissue. They are involved in tissue remodeling. They produce also extracellular mediators uh, that contribute to many processes within the tissue, normal tissue, or uh, their dysregulation and their malfunction that may affect the disease microenvironment.
I watched your research day video, and I kind of got the idea of what you're doing. You mentioned in that video as well as here, you study mostly the fibroblasts, and a lot of that is due to the role that they play in the microenvironment. And I was just wondering if any of the other cell types that you know of display any of the phenomenon that you're studying in terms of this switch to a lipid metabolism or a lipid-based metabolism?
Oh, this is a great question. Actually, we started to do some epithelial cells and some endothelial cells. The problem with those, they don't have a stable phenotype like fibroblasts. And you know how epithelial cells change from when they even can go through mesenchymal epithelial transition, right? MET. So the good thing about fibroblasts are easier to go, but we went there actually in endothelial cells. We noticed that if we do, I concentrate my work on chronological aging, which is basically the cells loss of proliferative potential. It's different from replicative aging, which is basically the telomere shortening part, which is very well established. We created a new concept, me and other investigators recently since 2005, which is the chronological lifespan, basically showing that quiescent cells, because normal cells in your body usually are quiescent. So we showed that in endothelial cells. This data, we never publish it because endothelial cells also, they are not, the phenotype usually is not stable. So this is why we are doing fibroblasts. But I can tell you that we have that in other types of cells. Now, I wish I can do some neurodegenerative disease like neural cells, but it's really hard to work with that in vitro system.
Why do you feel this research is important for the medical field? I mean, are there possible applications, do you think, for physicians in the future?
Yes. So let's start with the aging project. So the aging project, we shown that these cells there's a change in their metabolism, and that leads to pro-inflammatory responses, mainly arachidonic acid metabolites. So we measure those, the increase in lipolysis in these aging fibroblasts lead to the more production of this lipid metabolites. And one of these lipid metabolites are pro-inflammatory, like echinocide and other inflammatory, like prostaglandins and all of those. So we showed that it's elevated, and we published that recently in JBC, showing how these fibroblasts and their elevated lipid metabolites or pro-inflammatory modulator that came from lipid metabolism, or increase in lipolysis and increase in lipid free fatty acids, specifically arachidonic acid metabolites like echinocides and prostaglandins, actually affect cancer cells. So we have a co-culture system where those cells show that they are actually driving cancer cell proliferation and resistance to therapy. But we find out also we can actually inhibit this process by repurposing lipid regulating drugs like asopomax, which is a lipolysis inhibitor, in the normal cells, and that will sensitize cancer cells. And we are actually, after publishing this paper, now there is a talk that we actually gonna take that into clinical trial where we're gonna expand, examine the repurposing of those lipid or lipid modifying or lipid metabolism modifying drugs like asopomax, and there is another, a lot of statins also can change lipid metabolism in normal cells, and see how that affect. So this is one application, which is basically from the lab back to the bed, so bench to bed. Now the other project where we do the head and neck cancer, actually it started in the clinic. They have observation, it came to us, and they say, find why is that happening? Why these patients are not doing well? What's unique about their cancer? So we found out that this is what's happening in their cancer. So now we are proposing to use actually dietary modification through, dietary free fatty acids or high fat diet, therapeutic diet as an adjuvant therapy to the standard of care of radiation and chemo, and that will, I hope it will end up back into the clinic. So it's now started in the clinic or in the bed, came to the bench, and now it's going back to the clinic, from the bench to the clinic. And that's the approach. This is why what I always say, that we need the experts. There is an expert. Basic scientists are not patient experts. Doctors, physicians are patient experts, and we always have to talk together. So they found out something in their patient, they came to us, tell us, understand it. Now we give them the answer. Now they are the patient expert. They will take that. And so this is why it's really important. I think my research is translational, because either it goes from a discovery in the lab and then develop into going to the bedside, or come from bedside to the bench and back to bedside.
How do you think working in your lab helps prepare a medical student for a career in medicine?
So the good thing, one thing is about research is really an interactive learning experience for medical students. Okay. And what we do, I know we do basic science, but it always have to have some clinical application. So what it prepared them is, it prepared them in a way that they will understand the process itself, understand the basic mechanisms of disease, and they through research. So because they are not gonna only do experiments in the lab, they're gonna do literature review. They're gonna see other model system and other application of the same project, and that will open their thinking, open their, you know, um, open like doors for them for more knowledge. And that will help them as medical student to actually imprint that information in their heads, basically, to, because it's an interactive, because they did that. They actually went after the literature, they did the experiments, they did all of that. So that really helps medical students in this, interactive learning environment. That's what research really creates for medical students.
And if you could give one piece of advice to an aspiring physician, what would that be?
Okay, so one of the KCU value is intellectual curiosity. Intellectual. You have to be curious, right? Intellectually, and that's really important. That means you have to always keep an open mind. As a physician, I know that the pressure. I've seen a lot of residents I teach when I taught radiation biology and cancer biology back in Iowa. I know you always be under pressure, and I know it's really difficult to be a physician, but always keep your curiosity and intellectual curiosity up, and keep your mind open to any experiences, research opportunities, or even leadership opportunities. All of this, if you keep an open mind. This is what I always tell them. Always keep an open mind. Do not think that becoming a physician you are doing one thing. You can do many things, and you can advance the science, advance the profession, advance the career, advance the whole system, the whole healthcare system, by just keeping an open mind into opportunity in research and different other venues.
All right. Well, that's all the questions that I have for you, Dr. Sarsour.
Thank you, Brad.
And we'll be in touch with you soon.